afternoon, ladies and gentlemen. This is section 6.6 of Mrs. Quinn's geometry class, and today we're going to focus on 6.6 and a little bit of 6.7. To talk about rotational symmetry, we're going to start with its center. The center of a rectangular polygon is a point which is equidistant from all of its vertices. For example, in a square is a regular polygon because of all my side lengths being equal and all my angles being equal. And so I have some center point that is equidistant from each of these vertices. Now, hopefully you can see that I could draw a line of symmetry through at least two of those angles, and hopefully you can start to see that you could draw at least two more lines of symmetry. Now, if a figure possesses two lines of symmetry at point P, and I've already drawn them, it's rotational symmetric with a center at P. So I need to be able to draw at least two lines of symmetry at P to have some kind of rotational symmetric idea, or rotational symmetry. All right, let's look at different shapes. A regular polygon is a convex polygon whose angles are all congruent and whose side lengths are all congruent. For example, let's look at my triangle. If this is an equilateral triangle, all of my side lengths are congruent and all of my angles are congruent. To draw a line of symmetry, I must go through the angle, bisect the angle, and bisect this side length. Here I could draw a second line of symmetry, so I know this is my center, and finally a third line of symmetry. Notice that for a triangle, a shape with three side lengths, I have three lines of symmetry. Now for a square, here's my center, and I draw my first two lines of symmetry, and then I can draw two more lines of symmetry. And notice that for a square which has four congruent side lengths, I have four lines of symmetry. How many lines of symmetry do you think I'm going to have with a pentagon? Hopefully you're estimating 5. And notice whenever I draw this line here, it's going to bisect this angle and be the perpendicular bisector of the length opposite it. So here's my first line of symmetry, here's my second line of symmetry, my third line of symmetry, my fourth line of symmetry, and finally my fifth line of symmetry. Ooh, that last one wasn't good. Hang on. My fifth line of symmetry. All right, so here's our theorem that gives that idea. Every regular entagon possesses n lines of symmetry. So for how many side lengths are in my figure, I have that many symmetry lines. And they're all perpendicular bisectors of each one of its sides and the bisector of its angles. So for n-fold rotational symmetry, if I draw my center here, my line of symmetry must bisect this angle so that each of these are congruent and be the perpendicular bisector of that opposite base. And I will end up with 5-fold rotational symmetry. All right, so we're going to go to another idea here. If I have a regular octagon, how many lines of symmetry do you think I'm going to have? Oh, hopefully at this point you're going to tell me 8. 8 lines of symmetry, and it would have 8-fold rotational symmetry. So let's throw in another idea. What if I'm looking for angle CDE? Hopefully you remember from a previous chapter that we can find the sum of the degrees in a shape by doing n minus 2 times 180. And in this case, I have 8 sides, so I minus 2, I get 6. And 6 times 180 is 1,080 degrees. So that's my total number of degrees. So to find out how many degrees are right here, if I have this as my total number of degrees and each angle is congruent or equal, I have 8 of them. So I'm going to divide that value, 1,080, by 8 and end up with an angle of 135. So this is true for all regular polygons where you know your side lengths are congruent and your angles are congruent. You can find these angles by using this formula to find the sum of the angles and then dividing by your side lengths. Notice that that is different than if I asked you this. Oops. If I asked you how many degrees were here, notice that this inside portion is still like a circle. For its rotational symmetry, or how many degrees you could rotate it, you still have a circle of 360 degrees here. So if I was looking for this angle, I would take 360, divide it by 8, and get 45 degrees. So don't get caught up in the difference between this angle and this angle. All right? For tomorrow, I want you to find the measure of angle B for both of these. I'd like you to draw the lines of symmetry, showing them all going through the same center, and tell me what fold rotational symmetry each shape has. And I'll see you tomorrow.